So now that the introduction of the exam format is out of the way, let's focus on our first design experiment. So this worksheet is designed to familiarize you and to introduce you to the design template. So what do I mean by design template? You will see that here at the very end of the question paper, you are actually asked to plan an experiment using the apparatus to prove that to find some parameter from this equation. And you can see here underneath, this is your design template. So we are going to fill this up accordingly. And down here, I have even include a column to tell you the purpose of why do we want to write these things in this format. So when you are asked to, for example, when you are sitting in for your O-level exam, this is what you see. You will see a basically blank page, and what you need to do is basically to memorize this template and then just provide the plan in this format. And by doing so, there will be a high chance that you'll be able to capture all 6 points. But if you are able to capture like 5 out of 6 or 4 out of 6, it's fine, because ultimately your paper is upon how many marks? Do you know? Okay, so for your paper, oops, what is this? So, why? Oh, okay, should be here. So if you look at the syllabus document, you will see that your practical is 40 marks. So one session is about 20 marks, so 20 marks for A, 20 marks for B. So our 6 marks is like a quarter of the session. So it is quite heavy, but not really that important, because ultimately for the 40 marks, 6 marks is planning, right? That means for the rest of the 34 marks is based on precision rule, is based on how well you remember, how well you apply the precision rule to your working, how do you record the data, so on and so forth, how to do the graph, things like that. So majority of the marks for your practical exam comes from non-planning things. So these planning things is good, it will help you, but is it very critical that you die must get all 6 points? The answer is no lah. So you do your best. If you find that you are already overwhelmed by the precision rule, or that you are already overwhelmed by the units, then focus on that lah. Okay, the planning, just try to understand how the format work, and if memorizing it proves to be too much for you, then maybe memorize half or things like that. Okay, so don't go too hard on this. Okay, practical exam is not solely on planning, but rather the majority of the weighting falls on the precision rule, how you record the data, how you plot your graph. Okay, so normally when you are given a design experiment, they will actually provide some questions at the beginning to get you into the flow. So if you look at this question, basically this question is an experiment that you have done in secondary 3, and this is the heat capacity question. So you are given this number of apparatus, and then they will guide you on how to set it up. Basically they will ask you to boil water, so the water will reach 100 degrees C, and whatever metal that you put in will reach thermal equilibrium with the water, because metal is a good conductor. Then what you do is that you transfer this hot metal into different volumes of room temperature water. And so what happens is that when you put the hot metal in, the heat will transfer to the room temperature water, and you will be able to record the temperature rise in the room temperature water. And then you redo the entire thing, but this time round you will lower the very hot metal into a larger volume of water, and then you will get another temperature rise. So basically that is the flow. So to assist you in seeing the flow of the experiment, I have actually recorded a video of the steps that we have taken to obtain certain reading. So if you find that even after I describe the experiment to you, you are still not very clear, you can actually refer to the link that is on your worksheet. Okay, or you can scan this QR code in this YouTube video. Okay, or I think I will provide the link in the description. Okay, I will provide the link in the description. So normally, like I said, for session A, question 1, they will ask you some question to get you into the flow. So normally the very first statement, like here, you can see in the very first statement, measure and pour 20 cm cube. This most likely is going to be your independent, because you decided that you want to pour 20 cm cube of water into the styrofoam cup, and then after you lower the hot metal mass, you are going to get a reaction, right? So you can see that the second step most of the time is to get the reaction, which is in this case the highest temperature, right? Then after that, they will ask you to do some processing. Either you subtract, you add, you multiply, you square, or whatsoever. Then after that, you will then repeat the experiment, but with a different volume maybe, right? So that there's this first few steps will give you like a sensing of how the experiment should flow. Okay, so now I will skip to the part where the question be decided to going to ask you to plan a fresh experiment. So most of the time, before they ask you to plan for an experiment, they will provide you with an equation. So this equation basically is the step number 1 of your entire planning, because this particular equation will tell you what kind of reading that you should get, what kind of graph that you should plot, and what type of graph you should expect to see. So down here you can see that you are supposed to investigate this relationship. So what is the meaning of investigate this relationship? So step number 1, when you want to analyze the equation, is that you want to ask yourself which are the parameters that are constant. So normally for constant, I will use yellow color to represent. So rho W is density of water, which is a constant. Specific heat capacity of water is also a constant. Similarly, specific heat capacity of metal is also constant. Now this mass of metal depends, right? If I am changing the mass of metal, then the mass of metal will be changing, correct or not? So I'm not sure. So what to do? I'm going to scroll up and I'm going to see how many metal pieces do I have. So here you can see that I only have one metal piece. It's not like you give me one metal piece, then that's all I can do, right? If you give me like 5, I can like maybe tie them together, then I will get like 100 gram. And then if I got one more, then I will be able to get 150 gram in total. But now if you are just giving me one, then that means the mass of my metal piece here is also going to be fixed. I can't change that, right? So this means that the only thing that I can change is the volume of water, which is V, right? So the next step that I'm going to do when I'm analyzing this is I am also going to ask myself, right, which parameter are variables, right? Which are the things that I am going to change? So, well, I can change the amount of water. Temperature drop, temperature rise depends on the highest temperature that I'm going to get, right? So if you look here, they are asking us to find temperature rise of the water, right? So to find temperature rise of the water, what I will do is that I will take the highest temperature that I get. So when I put the hot metal mass into the room temperature beaker, the temperature will rise, right? And when it is the highest, I will record TH. So I know that temperature rise will be the highest temperature minus my room temperature water, and then my temperature drop will be my, so temperature drop when I put a hot metal into the room temperature water, of course my hot metal is going to cool down, right? So I will have a temperature drop. So now if you ask me what is this temperature of this hot metal, well, since this metal come from boiling water and it must have achieved thermal equilibrium while it is in the boiling water, then the hot metal initially is at 100 degrees C, right? And when you lower the hot metal into the room temperature water, then the room temperature water will heat up and the hot metal will cool down. So they will come to an equilibrium temperature and then it will stay there, right? So therefore, temperature drop is going to be this, right? So we know that boiling temperature, we start with 100 degrees C is a constant. Room temperature is where you get the tap water from. That means the only variable is your TH, right? TH is going to change, and because TH is going to change, T rise is going to change, T drop is going to change. So as a result, this one will also change, correct or not? So now if you look at this equation, can you see that this yellow one, the whole thing is a constant? So meaning that this yellow thing is going to be a constant. Let's call this constant M, not mass, constant. And then this variable, we can call it X. And then down here, this entire chunk of variable, we can call it Y. Meaning that we can actually reduce this entire formula into Y equals to mx plus C, whereby C is 0, no? Correct or not? So by doing so, we know that we can investigate whether this left hand side is equals to right hand side by plotting T drop over TL against V. And if this equation is true, I am going to get data point that is going to spread out and allow me to draw a best fit line that is straight, because a straight best fit line will give me a constant gradient. And if it cuts 0, 0, and if it has a constant gradient, it would mean that this particular equation does describe how the data is going to spread when I lower a hot metal into a cup of room temperature water, right? So with this understanding, just by looking at this, I will be able to think that, eventually in my experiment, I am going to have certain set, I'm going to put different volume of room temperature water, and then after that I'm going to lower a fixed mass of metal into this room temperature water, and I'm going to record the highest temperature that the room water will rise to. And then from there, I'm going to work out my T drop, and I'm going to work out my T rise, and then after that I have to form this ratio, the blue one, TD over TL. So I will get data, and with this data I'm going to plot a graph of TD over TL and V, and then I would expect to see that all these data will give me a spread of points. And I know that if now I draw a best fit line through this spread of data point, if it is suggesting a straight line, then I can confirm that, well, the trend does suggest that it has a fixed gradient. And if it cuts 0, 0, then even better. It means that it is really matching the equation that is given to me, right? So now I have a sensing of what I'm going to do, and then I will look further on what should I include. So in my writing, I need to make sure that I talk about what I want to keep constant. I also need to give a full description, so this part is the longest part. And then I need to tell the examiner what kind of graph I'm supposed to plot. And finally, I'm going to explain in my instruction how specific heat capacity of metal can be found from my graph. So if you look at this, well, I can score this point by just saying what I want to keep constant, and basically I have captured that because these are the things that I want to keep constant. I want to keep, for example here, the mass of metal constant. I want to keep density constant. I want to keep specific heat capacity constant. I can even say I want to keep my room temperature water constant as well, right? So these are some things that I can keep constant. I can get the marks, right? Okay, this full description on how to perform the experiment, I need to spend a lot of effort doing. So I may not want to capture this mark if I'm running out of time. Next, a statement of graph that I want to plot to test the relationship. Well, I already know what graph I'm going to plot, right? Because from the beginning, I've already established that, oh, this is what I want to plot. Because by looking at this equation, the blue one are my variable, and the yellow orangey one is constant. So I'm expecting a graph that is a straight line. So I already know what to plot, and it's a one-liner. So I can score this mark. Then how do I get CM? So where's CM? Oh, CM is right here. So what I see is that, oh, okay, now I know that now the gradient of the TD slash TR versus V graph is going to be, right, this gradient here is going to be this chunk of stuff which consists of rho W, CW, MM, and CM. So now if I look at this, I want to get CM, right? So I make CM the subject and I replay my algebra. I will be able to do this. So I can find CM as well, right? So I can find this relatively easy and I don't need to spend much effort. So because of that, when I'm doing the planning, let's recap at this point, I will focus on the equation first, find out what are the parameters in this equation that is constant, which ones are variable. And once I do that, well, I can see this now very clearly, that it takes the form of y equals to m x plus c, and this is exactly a linear equation, the general form of the linear equation. From there on, I will just imagine that, okay, in order to do that, I will need to have a V column because I need V over here. And then what are the readings I need to take? What kind of table I need to take? Then this is how I generate my graph. From then on, I would know that at the gradient position, that is where I can find the CM. So once I have all this, I can now begin filling up the template of the design.